This is the webinar number 4. Good morning, everybody. This time we're going to talk about setters and getters in object-oriented programming. They're also called mutators and accessors. It's a very, very commonly used and very popular pattern, which I think is actually an anti-pattern. And I will try in the next hour. I will try to prove that and give you some examples which will actually help to prove my point. But first of all, let's start with an example of what is getter and setter and how they actually look in Java. Again, I'm going to use Java as a language. Here's my code. And it's a class called dog. This dog has a nickname, and we can get the nickname, and we can set the nickname. So as you see, there is a private property inside the class, and there are two methods. The first one is called a getter, and the second one is called setter. By the getter, we can get the name of this dog, and by the setter, we can set the name of this dog. It is very typical. I'm sure you've seen this a lot of this code in Java, in Ruby, in all other languages, and this is how actually Java is encouraging us to work with our objects, to design them. And it's even called, there is also Java Beans idea there, like the API or specification. It's not exactly the API, but it's a set of, it's a specification of the Java is encouraging us to use this design. And for every private property, or for most of the private properties, they encourage us to use getters and setters. Or mutators, this is called mutator, and this one is called an accessor. And the main reason here is that that idea was introduced mostly. That's what I've read on Wikipedia. They say that this mostly introduced in order to make the encapsulation better, so to encapsulate or to hide the details of the object, to hide this private property, so that nobody can access it directly. So there is a private keyword here. So from the outside of the class, if I'm doing like dog equals to new dog, then I can just say dog nick equals to, I don't know, Jeff. So that's not possible. So in order to prevent us from directly accessing the property of the dog, then they introduced this idea of setters. And now I have to set name, and then I call it like this. That's the only way I can actually access the nickname or the name of the dog. So that's what the setters and getters are for. And again, in order to read the property, I can't just do like this. This is not legal, but instead I have to do get name, and then I get the name of the dog. That's the idea. That's what this whole thing was introduced for, and which is which is definitely better than directly accessing the private property of the dog, because here in the method we can say, for example, control what's being said, and we can say if name is empty, then we just throw an exception. Legal, blah, blah, blah. So there's some exception which is thrown if the name is empty. We can't do it if we let everybody access the nickname directly. That's all true. But, so now we understand what it is. Now we know what these getters and setters are for. My point here, that I want to say that this idea is wrong. So introducing these methods for private property, when you have a private property in your class, and then making setters and getters for this private property is totally wrong. And we shouldn't do this if we are in object-oriented programming. So let me get it back. So now we know the example, what the setters and getters are for. And there are a few reasons. I'm not the first one who is saying that these things are wrong and they shouldn't be used. There are many articles about that, and there are many reasons why. There are many articles and people saying that they are wrong, and there are a few reasons that they give. The first one is called tell and don't ask. The reason here is that it means that when you are when you're dealing with the elements of the class, with the elements of the object, then you shouldn't get something out of the object and then do something with it. Instead, you should tell the object what you want to do, and then let the object handle this request for you. So you shouldn't. That's how it's explained. So instead of asking me as an object to give you some piece of data or another object, and then you do some operations with that object, instead you ask me. You should tell me what you need to do, and then I will do it for you. So it's called tell and don't ask. So don't ask me to provide you some information which you can work with, but instead tell me what you want me to do for you with the information I have. That's the main idea. Why it's better? Why it's better to tell? Because it's better for encapsulation, and it's better for cohesion. So we keep the information more close to the place where we keep the data closer to the place where they are being processed. So I have the data and I know what to do with the data. Instead of getting this piece of data to you and then you manipulate with them, you let me work with the data I encapsulate my way, the way I understand it. That's the reason behind this. That's the logic behind this reason. We'll continue. We'll discuss it a little bit later. The second one is that, again, why these getters and setters are bad. Because let me explain how is this related to the setters. So this tell and don't ask. Because when you get the name is quite primitive, and it's should be string. It's my mistake. Yeah. So the name is quite primitive, and when we get the name from the dog, then you do something with this name. For example, you check whether the name is empty or not. But instead, you shouldn't just first get the name out of me and then do something with it. But you should ask me whether my name is empty or not. That's the thinking. The second problem is that by using setters, by setting the information into me, by sending me some data and asking me to set it here locally, you're kind of violating the encapsulation idea. So you are basically, even though you use the method there, and the method is called setName, you're still setting something into me. Of course, I can. This request goes through the setter method, and it just doesn't go directly to the property. But still, what's happening is that you're giving me the piece of data and you're injecting it inside me. So this is you're kind of violating the encapsulation idea, because there's a border of the object. There is there's me and there's you, and what's happening inside me. You're not supposed to know that. You're not supposed to just set the piece of data inside. What you want me to do and how you want me to work with the data, and then I will do that for you. So even though it's better that using directly accessing my properties, but you're still doing the same, even though you go through a method, even though you call the method and the method does that, but you're still doing the same, violation of encapsulation. You're still injecting something into me, into my private area. And also, another reason, I mentioned all this in the article, so I'm just kind of summarizing them. And my point is that all of these reasons are not as strong as the one I'm going to give you a bit later. So all of this, I'm just getting to the main point. So number 3 is that we kind of, by using getters, not setters, we just discussed setters. Let's see the getters. By using getters, we expose internal implementation details, more or less. Like in the case of the dog example, I have the name of the dog. I'm the dog. I'm the object, which is the dog, and I have my name inside me. And when you ask me to give you this name, which is type string, then I expose my internal implementation. I give you, the type string. You know that inside me, I have the nickname or the name in type string. So you will rely on this information, and you will use this my internal information you will use for your benefit, and you will rely on it, and you will work with the name as a string, which is not the type which you require, which I expose publicly, but this is the type of the thing I keep inside me, which is the type of the property which I hold here. So I don't change this type. I have string inside, I give string back to you, and you rely on this. If I want to change my implementation inside me and start using instead of string, I want to start using something else, then all my clients will be in trouble, because I expose them the type which I store locally. if I'm just using getters, because getters is supposed to just get what I have and return it back to you. It's not changing the type, it's not changing the interface, it's just getting what I have locally and returning back to you, which means that you kind of see what I have locally. You see my type, more or less, because I'm not changing it on this path, because the setters is not supposed to change it. It's just directly returning what's inside without making any changes. So that is kind of a problem for a big design, because all of the clients will depend on this type. Well, in case of string, it's not a problem because it's commonly used type. But if it's something more complex, then all of the clients of me as an object, I'm an object, I expose my internals, and you will all depend on my internals. And then if I decide to change it and start saying, instead of keeping the name in type string, I'm going to use some other type of text or whatever, then I will have to update all of you. That's the concern. But all of these things, all of these concerns are not, they're kind of technical and not really conceptual or philosophical. I want to give you another one, which I think is way more important and it kind of covers everything I've said before, and it's even stronger. So my point is that by setters and getters, we are treating the object as not a real object, as not a something which is, we are treating the object without due respect. We don't give enough respect to the object. We don't see it as a self-sufficient and strong and self-sufficient. That's the word. So we're not treating the object as something which can work on its own, and we have to communicate with this living organism or living creature the way this organism expects us to. But instead, we're treating this object as a bag of data, as a collection of attributes, collection of properties or data elements. And what we do is that we're just using this collection of elements as a temporary storage of data. And that's what I think these Java beans were kind of introduced for. So they are using these beans as temporary storage of data with maybe some functions, some methods attached to them for convenience of manipulations of the data. That's what actually many people think objects are. They think that object is a collection of attributes or data with a number of functions attached to this data for the convenience of manipulations of them. So it's just not really convenient to sometimes to talk with some numbers inside. It's better to get some summary from these numbers, for example. And then we call it an object. So we basically inject something there. We set and set and set and set. So we make like a number of set calls, and then we're making some get call, or we're calling some method and saying, how about you calculate calculate something on these numbers. So if you want to give you a metaphor, let's say I'm an object, and you want to, and there's a pen, and you are another object. So you want to give me a pen. You can do it like this. You can give it to me and say, here's the pen, like do something with it. And I will get this pen and I'll put it into my pocket. That's the normal interaction between you as a living creature, self-sufficient object, and me, self-sufficient object. It's my decision what to do with the pen. You gave it to me, I put it in my pocket. That's the normal transaction. That's how objects should interact. And this is what the setter is doing. You get the pen and you put it into my pocket. You don't give it to me, you just go directly to my pocket and say, set it there. So you're not seeing me as something, you're not respecting me enough, because you just go directly to my pocket and just do this operation for me. Because I gave you actually this set method. So I gave you this set name or set property or set whatever, because this is a setter here, and you just use this setter, and the pen goes directly to my object. It's more like a philosophical questions of naming, actually, not just actual implementation, because you may say that, let me give an example. Let me share the screen with you. So you may say that, what is the difference between, this is what I'm proposing to do, this is what I'm suggesting to do. So here's the same class dog. So let's see the previous example. This is what we had before. This is setters and getters. So you have this private property called nick, and we have get name, and we have set name, setter and getter and private property. This is what I'm suggesting to do. I'm just suggesting to change the name from set name, from get name, we change it to name, and from set name, we change it to rename. That's the only thing. So I'm suggesting what I'm saying is that just using this set and get prefixes is the problem. If we just remove them and start using just names which will tell us, which will be more respectful to the object, then we will change our understanding, our thinking of the design. So we will design in a different way. Instead of setting me the pen and giving me the pen and injecting it into my pocket, you will call the method called rename, and then I will decide what to do with that. But it's not just about the implementation here, because it's exactly the same, but it's about of how you see me interacting with you. You are not seeing me as a bag of data which is ready for your pen or for your name or for your something, for your data to be injected into me. But instead, I'm someone who knows what to do, who understands what the data are about. So I understand that you want me to rename me. So you want me to change my name. So you don't just go into my brain and change the name over there, like paying no attention of who I am and what I'm doing, and I'm a dog or not a dog. You just set the name into me. Instead, you're asking me in a more polite and respectful way to rename myself. And if you start renaming all of your methods this way and naming your methods this way and giving them proper names instead of set and get, you will realize that some of them are not actually a good fit for your object. Some of them will actually not, you will question yourself more of whether your design is strong enough and good enough for having so many methods, for example. So again, the problem is with the naming, not with the usage of data. That's what I'm trying to say. And let me stop this screen sharing. Yeah, so the idea is that, again, I want to open my article. And there's the same example with the dog in the article and the weight of the dog. So we can set the weight of the dog, or we can ask the dog to do something with the weight, or we can set the ball to the dog. So we have a dog and we have a ball. So the ball, we just give the dog, and the dog makes the decision what to do with the ball. Maybe the dog will act exactly as a bag of data. It's up to the dog. So maybe the dog will just be internally will be implemented as a collection of data properties, attributes, and it will have the method which is called like take the ball, and the ball is passed in the parameter, and then the ball will come in and the dog will put it inside. But from the outside, from the surface of the dog, from the interface of the dog, it should look like the dog is smart enough to understand what to do with the ball. We should not use this get and set prefixes, because they tell the user, they tell you as my user that I'm stupid enough to accept whatever you want, to accept whatever you give me, and not just give me, but you put it directly to my pocket, or you inject it directly to my brain, or you don't give me the ball, you're just injecting it somewhere inside me, which is totally wrong if you're thinking like objects. If you're thinking like data plus methods, like in procedural way, that the method, like the object is, like I said, object is a collection of attributes plus methods attached to them, then this is the wrong thinking. And if you're thinking like that, then yes, you need setters and getters, which will help you to manipulate with the attributes. But this way of thinking should go away if we are in object-oriented world. Instead, we should see an object as self-sufficient living organism which is able to react to our requests and respond to them, and respond to them in a way the object wants to respond. But unfortunately, it's not the case. Look at for example, like the example from Android API. There's activity class designed by Google, and this activity class has, I don't know how many, but over 20, maybe over 30 setters and getters. So which makes it really, can you imagine a real life object or a class like this dog, for example, or a ball or something which is real life, which is actually a living organism, which is something which you can understand what it's doing, and it has 30 different setters, so 30 different 30 different interfaces, 30 different control points where you can do something with this object, and the object will react somehow. It's not possible. It's just too much. It's too big. But if you thinking like a collection of data, like a bag of data, bag of attributes, that's perfectly fine. You have 30 different attributes inside, and you have 30 different methods which will inject, or 40, I don't know, maybe more. There are in total like 250 methods in this class or interface. This is ridiculous. So they made it possible. They made this design because they are thinking in a procedural way. They're thinking that this is a collection of data which we store over there, and of course we need our clients to give an ability to change this data. And then they change this data, they set something, and then they call something when it's ready, when it's set. So it's obviously correct for procedural thinking, because the procedure is, we have the attributes and we have a procedure attached to it. The procedure helps us to manipulate the attributes. So if you stop thinking like that and start thinking like objects, then the main benefit, that's my final point, and then we'll have questions. And the main benefit of that will be that your objects will become smaller. So that's what you're going to achieve if you stop using setters and getters. Your objects will become smaller. I'm not saying that they will be immutable, but I think that all objects should be immutable. I mentioned it in one of the previous webinars. But even if you don't want to use immutable objects and you want to stay with mutable objects, even though your objects will become smaller, which is the most important thing you can achieve in object-oriented programming, is to make your objects as small as possible. Because if they are small, then they are more cohesive, they are less coupled, like, I mean, these data manipulations and algorithms are less coupled, and it's way easier to test them, it's way easier to mock them, everything is easier, the whole design is better. So the main strategy, the main goal is to make objects as small as possible. Ideally, it should be a few constructors, and then 1, 2, maybe 3 methods, and then a few private methods. So ideally, the object should fit into 2, maybe up to 3 pages on the screen, maybe even less, and including comments and everything. So the object should be understandable and readable in just one first look. So if I look at the object, I understand what it's doing in probably a few minutes. You cannot achieve this if you allow your users if you encourage yourself and your co-workers and the co-authors of your object to use the setters and getters, because there's always a temptation to add more. You have one setter, how about we create new setter? We have a dog, we have a weight of the dog, we have a name of the dog. How about we add the speed of the dog can run, and we can name the owner of the dog, we can name the price of the dog, we can name the home location of the dog. All of these attributes we just added there, and it's so easy. We add the attribute and we add the getter on top of that, and setter, getter and setter. In all popular IDEs, there's a function, there's like a feature in user interface to create a private property with the setters and getters. So the whole interest is encouraging us to use this anti-pattern. And I'm saying this is wrong. I'm trying to say that we shouldn't use it. But yeah, there's a huge temptation. Everybody's using that. But it's wrong. So the main goal is to make objects smaller, and ideally to make them immutable. Let me show you again the dog example. And we'll see how this thing can be immutable. So this is the code which we have. This is the code, and it's mutable. So as you see, this rename function, it changes the what's the typo here? It changes the internal property of the object, and this class is obviously mutable. This one is immutable, and this design looks perfect to me in all possible senses. So this is, I think, the perfect design of an object. So the private property, which is a nickname of a dog, it's final and it's private. So nobody can touch it, of course, and nobody can change it except the constructor. And then we have a constructor which actually actually encapsulates the data which come in. So the data comes in, and we encapsulate it here. And nobody ever can change it after the object is constructed. And then you want to see my name, you get the name with the getter, which is the getter, but it's not a getter. You're asking me what's my name, and I'm telling you what's my name. I'm not giving you the nickname from inside. As when you see it from here as a designer, as my client, you will see it like this. You create me first, and then you say dog name. So you're asking me, what's your name? And I'm telling you what's my name. And then you're saying, and then you want to rename me if it's possible. For example, I was Jeff, and now you want to call me, I don't know, Sunny. So it's another dog. And I'm saying, rename. Now my name is Sunny. So you rename me, it was Jeff, and now it's Sunny. It's another dog because it has another name. Well, in object-oriented understanding, in OOP understanding. In real life, of course, it's like maybe it's the same dog staying with it, like just a different name. But in OOP, it's a new object, which is called Sunny, and we create a new instance of the same class, and it's doing by method rename. So this method rename is actually it's not a setter as you see here. It doesn't look like setter, it doesn't work like setter, even though we are changing the name. So you will get to this design if you stop using getters and setters. If you get rid of these prefixes, that's what I'm asking for. Just get rid of prefixes, set and get. Because when even if you don't have the setter, sometimes I have this question, like people are saying that, let me stop that. Somebody's saying that I don't have setters, I just have getters. So my design is my immutable, and I just create an object, and then I encapsulate everything in the constructor, and then I have a number of getters just to get some data out of this. And I use the get prefix because it's convenient, like get name, get weight, get price, get address, whatever, get parent. We don't have setters, so what's wrong with that? The answer is that this get and set prefix, they are coming from getter and setter pattern. So it's better to stay away from that. It's better to get rid of the whole pattern altogether. And that's why this get prefix is, it's part of the anti-pattern. So it's better not to use this prefix at all. So just give your methods just normal name, like name, weight, parent, whatever. You're just asking me what's my parent or what's my address, and I give you, and then you get the address. So the name of the method is address instead of get address, because get address means that there is somewhere set address expected. Or the thinking is expected that there is a set address, and it's expected that there is an address property in the object. So it is expected there's a direct path from setting address and then getting address back. So it's expected that this encapsulation border is violated. The encapsulation principle is violated. So you not any longer respect me as somebody who can tell you the address, but instead you're coming to me and getting the address from me. You're just getting it out of my pocket. So I have a pen here, and instead of coming to me and say, hey, give me a pen, you're just saying get pen, boom. Like, on the way of thinking, it's wrong. That's my point. And again, if you make it, if you start using real names instead of set get, then you will realize that you can make a huge object with so many different names and so many different names. You will run out of names quite soon, and it will look to you. You will see that if you look at the interface of your object, and there are, for example, let's get this activity example again from Google, from Android API, and they have 250 methods. If you get rid of this set get, and they also have like other things there, not only set get but also do and something else. So if you get rid of these prefixes and start naming your methods in giving them real names of the actions you expect to happen with the with your objects, then there will be a big problem to invent these 250 names. It's going to be like real problem, and you will quite soon realize that maybe after, I don't know, 20 names or maybe 15 names, you will see like it's time to break this whole big, huge monster object into parts and make smaller objects, because it's going to be a mess if you make 250 names of different methods, of different operations, of different things you want me to ask to do. It's going to be too smart dog or too smart activity for one user to understand. So this get set, they encourage us to make our objects bigger, like Java beans, like this activity in Android, which is a wrong design, which is procedural design. Maybe for the procedure, it's a good way of reducing complexity, but that's only the first step from programming in one function without even any objects, and then we get into some classes where we group some data together and we put some procedures in there, which is a good step forward comparing to just C code when we just have functions with 15 parameters. So instead of encapsulating into an object, we just pass a lot of data from function to function, and then we have functions with many parameters. That was before, and now we have then people started to use these groups of they group data, and we put data on top, and we put functions on top of data, which is the first step. But this is not object-oriented thinking. In object-oriented thinking, objects are quite small. Like I said, 2-3 methods. That's a perfect object. 2, 3, maybe up to 5 methods. I'm talking about public methods. And then we have like private methods as many as you want. But on the public, on the surface of an object, it has to be 1, 2, 3, maybe 4, up to 5 methods. If you have more than 5, then something is wrong with the design. You're probably thinking it wrong. You're doing something wrong. And if you name your methods in the right way instead of setting and getting, then it will be easier for you. So that's, I think, my point about all this. I'm ready to answer your questions. There's a QA section on the right. So give me your questions. And in the meantime, while you're typing, I'll try to answer a few questions from the blog where people are asking about all this idea. So the first question is that, what if my objects are not immutable and we still want to make changes to the data? For example, we have a bank account, which is not a mutable object, which is an object. Well, it can be designed in a mutable way, but it is in most cases. Well, we discussed this mutable and immutable thing on the previous few webinars. So my understanding of immutability is probably a little bit different from traditional understanding. But let's see the traditional understanding. So we have an account which has a method to change the balance. So I can ask the bank account to change the balance and add a few dollars to it. So what's wrong about saying set the balance to, it was $100, set it to $200? So why can't we just name it set balance $200? Instead of, in my opinion, we should say, well, this is the typical approach, like make the method called set balance and then pass the $200 there. But if you look at this situation and you remember that setters and getters is a wrong thing to do, then you will question yourself. There is something wrong. I'm using set balance, and I know that setters and getters is a bad thing to do. So how about I refactor that and do something else? And then you will realize that instead of calling set balance, you can probably call the method just balance and then parameters. But it's not really what we want to do. We want to think even further and see that we shouldn't change the balance on the bank account. We should instead ask the bank account to add some data to the balance, for example, or reset it to 0, or add some information, add some numbers there. So then you will introduce a few more methods, which will be called reset, and then maybe add some amount, or deduct some amount, or I don't know, multiply, or apply some rates. So you will actually stop seeing this balance as as a dumb and stupid and passive place where you just tell this place what to do. You just put the data there, and that's it. You don't expect this thing to think. You don't expect this creature to think back or to react back or to do something smart. You're just using it as a place where you put the data you want. You will stop that and you will say, hey, this guy is smart. And how about we talk to this guy with more respect? We will say, hey, how about you add some information? How about you deduct some numbers? How about you recalculate yourself or reset yourself? And then the whole design will be changed. So if you put aside this set get thinking, you will start thinking in the more object-oriented terms, which will actually improve the entire design. Everything we're talking about here, actually, on these webinars, is very practical. We're always aiming to make the design simpler. That's the whole idea. It just has to be as simple as possible. And to make it as simple as possible, objects have to be as small as possible. And to make them as small as possible, we need to change the way we think, to change programmers think. So when we start thinking differently, then our design will become better. Because look at this again, activity class from Android API. Who made it? Why it was made this way? They're not so probably bad programmers working in Google, but they created this stuff. So why did it happen? Because that's the way they think. They didn't want to hurt anybody with that. They just think that this is good, and they made this ridiculous and wrong design, which we all have, like everybody in the world are now using this Android classes. So we need to change the way we think, and then the whole design will improve, and then the maintainability and the size of our classes will decrease, which is good. Okay, I have some questions from you guys. Let me start with this one. You're mixing too much in the same discussion topic. Get and set prefix are okay if not misused. It's misused in 80% of cases, but it's not a problem of get set names, it's a problem of designer. Well, it's a problem of designer. It's a problem of programmer, like I just said. Definitely, it's a problem of the way we think. So about 80% of cases and misused, I don't use setters and getters for the last few years in all Java code I write, never. And I don't see any problems with that. So I don't understand where exactly they have to be used. So what's this 20%? Like why and where these 20% are, and why these 20% cannot be designed in a better way. So I kind of disagree about this 80%. I think they're misused everywhere, just everywhere. And if I'm wrong, show me the example. Just show me the class where the getters and setters are there, and there is no way to refactor it to get rid of the set get prefix and give the normal names to the classes, to the methods. I haven't seen it in a few years when I stopped to use this get and set. I was using this get and set prefix like 3 years ago without a problem. But then I realized that there is something wrong with that, and I stopped that, and I don't have them anymore. And then the second part of your question, it's not a problem of names, it's a problem of designer. 100% agree. It's a problem of the way we think. So it's not a problem of the name. If you are like smart enough and you realize this, like what exactly is happening, then you can probably like handle this and give this get set names to the methods. But why? What's the point? If like why making this life more difficult for you, even if you're smart enough to handle that, but why making it more difficult? Instead, just give normal names and make your life easier. So yes, for a highly like skilled designer who understands what's going on and who knows the difference between object-oriented and procedural programming, then yes. But anyway, I think I answered your question. The next one, suppose we want to paint a dog. It can't paint itself. We need a painter to change its color. How would this painter change the color of the dog without having access to the dog color property? Remember, a dog doesn't know how to paint itself. So we have a dog and we want the painter to change its color. So the painter has to access the color change the color of the dog without having the access to the dog color property. So the dog cannot paint itself, but at the same time, some painter can go inside the dog and paint it. So in this case, our design of the dog is wrong. We just incorrectly built the model of the dog from real life to to our object model. Because if the dog can't paint itself, then we need to redesign the class. Because only the dog can paint itself. We need to encapsulate all the functionality inside an object. We are not. It's wrong to let anybody to change anything inside me as an object. So I'm an object. I'm a dog. I have colors inside. I have weight. I have name. I have something, and then you're saying I can't paint myself. I can't change my color. That's wrong. It's just the wrong design of a dog object. So no other foreign objects can do anything inside me unless just that's it, period. Nobody outside me, no foreigners can do anything inside me. They can only ask me to do something, to manipulate with the data, to manipulate with, not just with the data, just to do something. It's my choice what to manipulate the data or not manipulate the data. Maybe I don't have a data at all. Maybe it's like I'm designed in a completely different way, and I don't have the data. I'm just a random object which does something on the fly without encapsulating anything. So you come to me and say, paint yourself, and I'm saying, okay, I'm painted. And then the next moment you ask me, what's your color? And I'm saying, you come to me and say, painted red. And then the next moment you come to me and I'm telling you, yes, I'm red now. I did this. I did what you asked. You asked me, paint yourself. And I did what you asked. And then the next moment you're asking, what's your color? And I'm saying it's blue. Because I'm a bad object. I misbehave. That's my choice. I don't listen to what you're saying. I just don't want to paint myself. So this is my choice as an object. You can't control my behavior to 100%. You can just ask me what to do and then expect me to react to your request later in the way you expect. But it's still my choice whether I'm going to be painted or not. That's the idea. I hope I answered the question. Okay, let me try another one. I'm trying to select the next question, but for some reason it's not selected. Okay, I'm gonna just read it. OP should represent the real world. In the real world, objects are mutable. A dog is the same dog even if it weighs less or its nickname is different. How are you dealing with this principle? I think that some objects are okay to be mutable, some are not. That's a good question. We discussed that on, I think, two webinars before, and you're right. The objects should represent the real world. And some objects in the real world are mutable. Actually, most of them are mutable. Actually, all of them are mutable. But the mutable and immutable, an immutable object, you can see one of the previous webinars. An immutable object doesn't mean that the immutable is that it's dumb and it can control the real world and it can actually manipulate the real world. So an object is immutable in a sense that it represents one real life thing. So I am a dog here, and I represent a real life dog. And when you're coming to me and asking, change your name, then I can just go to the real life dog and put the new name over there. So, but if this name is a property of a software thing, then it should be immutable. But if this name is a property of a real life thing, then it just goes through me and I don't keep it here in a software place. So it's a question for the previous webinar. You can look for it. It's called Immutable Objects Are Not Dumb. It's a title of an article. And there is a webinar which discussed the difference between like constant objects, which keep all the information inside and never change anything inside memory. In memory, in computer memory, and objects which keep something in memory, but something else is kept in the real world. Like, for example, a file object, the class file in Java. The file represents a file on disk, but you can, for example, you can write something to the file. You will update the content of the file or the length of the file or update or the time of update. And this property is really dynamic, and it's not kept here in the file object. It's somewhere in the real world. So we discussed that before, but I would suggest to read it. So that was the question I was answering. It's done. Let's see one more. What about this one? What about Java frameworks that impose the need to have public getters, setters, and default constructors? Yeah, that's a good question. So we still have, not still, but we have a lot of Java frameworks. For example, JAXB, which is Java to XML mapping, which are asking you to actually make these getters and setters, and you have to name them get and set. So they encourage you to use prefixes and default constructors, like you just said. It's just a big problem, and I really don't like this situation, and that's why I'm trying not to use these frameworks as much as possible. But sometimes you just have to. So it's just, if you have to, you have to. There's no choice, because the whole Java world is thinking in these getters and setters, and we have to. Sometimes we just have to use what they ask us to use. So unfortunately, it happens. That's my answer. This one: how is it possible to have only 5 methods for entities classes like customer, supplier, address? Yeah, it's a good question. So how is it possible, like I just said, to have less than 5 methods for the objects? And then the question is, like, let's say we have an address, and in the address we may have multiple, like more than 5 methods. Just break it down into smaller classes. For example, you have in an address, like you have a customer, and the customer may have an address, a city, a country, a zip code, a phone number, a balance, I don't know, a name, a title, a list of departments. There could be multiple things which are supposed to be exposed as not getters, but these normal names. Then you just group them into sub-objects, smaller objects. An address, you can put together address, zip code, city name, a country, a phone number, and then call it an address. So the customer will have a method which is called address, and then in the address object you will have all the sub-objects, and then in there and further and further. So try to keep, not try, but it's really important to keep the number of methods in a class, in an object, in a class, to less than 5. Maybe in very exceptional situations can go a little bit more, and maybe 5, maybe 6, 7. But if I see a class or like an interface with a public 7 methods, it's definitely something wrong. Something really wrong is going on there. 7. I'm not talking about 200. I'm saying about 7. Because when I see 200, that's just obvious that it's not a design. It's just a bunch of procedures. So it's possible for every class. Answering your question, for every class, when you see more, you just group these things together and create sub objects and return them. That's it. Let's try this one. You've mentioned a few constructors. Yeah, I said before that an object should. That's what I see a good object. It has a few constructors, as many as possible. Actually, you can have many constructors. 10 constructors, 15 constructors. There's no limitation for that. So the amount of constructors could be like really big, as many as you can. Because the way you construct an object, it's up to you. You have to give me a lot of flexibility of how can I construct your object. That has to be like flexible for me. But then only a few methods when I start to communicate with an object. So yes, I've mentioned a few constructors. So what to do with those languages which do not support overloading, multiple signatures, for example, Python, Go, JS, and so forth? It's just a problem it's just bad languages. Well, for example, PHP. In PHP, you cannot make more than one constructor. And for example, in Zen framework, they are, if I'm not wrong, they're using you just pass an associative array into the constructor. So you have one constructor always, but you pass as a parameter, you pass an array of actually a map of properties, and then inside the constructor, you decide what to do with this map of properties. So you just find a workaround. Maybe this is maybe the best and maybe the only workaround. So you just pass a map, a data structure there in the constructor into one single constructor, and then inside the constructor you put the logic which decides what to do if if something is present, if something is absent in this map. So that's the best thing you can do in these languages. But I would suggest not to use these languages, and that's it. Well, JavaScript, there is no choice, but Python, Go, I think they're not really not strong OOP languages, especially Go. Let's try this one, and we are close to finish. What about collections? For example, you want to add a new apple to a basket. Actually, it modifies the basket itself. Should you return a new instance as well? Or should we rely on reference and share just an object, collection of apples? It's again the question we discussed before. So you may have immutable collections and you may have mutable collections. It's up to you how to design. Depends on where you want to keep the data. If you want to keep the data in memory, then immutable collection will be slower on adding data, but it will be probably well, depends on it just depends on the design. So you can have both. You can have mutable collections or immutable collections. It's not immutable, like fully immutable, like constant collections, which, like you said, when you have a basket of apples and then you put another apple in there, then it's like a new basket because it was 5 apples before and now we have 6 apples. So this is the basket number 1. This is basket number 2, which is one way of designing that, which is better for many things, for concurrency, for side effect free, for many good design, for many good things for the design. But you can do it in immutable too. So we discussed that before. I'll send you the link. One more. Wouldn't this tell, don't ask paradigm somehow violate the single responsibility principle? That's a good question too. So you're actually saying that if my object always expects you to tell me what to do, and then you want me to do different things, then the single responsibility principle, which says that one object has to be responsible for one responsibility, to be responsible for one action or for one algorithm, then definitely this idea of expecting you to tell what to do in different ways will definitely violate this principle. And that's why you will have to make your object smaller. Because if your object has 200 methods, then definitely it's a huge violation, terrible violation of this principle. And to get rid of that, you will have to make it smaller. Because if you keep in mind the single responsibility principle and at the same time this principle of tell and don't ask, I expect my clients to tell me what to do, and I never give them my internal details, and then at the same time I want to be responsible for one thing, then my design will be just one, maybe 2 methods in my public, in my front end, me as an object. So I will design myself. I will always contain 1, 2, maybe up to 3 methods, and that will be enough for me. Because I don't want you to ask me for the data. I'm always expecting you to tell me what to do, and I want to be responsible for just one thing. Then the design of the class will be perfect. It will be small, cohesive, easy to understand, easy to maintain, easy to unit test, easy to mock. Everything will be easier. So the entire application will benefit from that. And one last question, and we are finishing. Can you describe the signature of a white dog? Is it new white dog or new dog, new color? It depends. It's up to you. So you can make many classes which will. You can make it's like a trade-off. You can make classes which expect with big constructors, and they encapsulate more inside, and constructors are bigger. For example, I'm the dog, and I have inside me I have the color, which I keep locally, and then I have a method which for example asks me whether I can hide in a forest. So if my color is I keep the color inside, and if my color is for example black, then it's difficult for me it's easier for me to hide in the forest comparing to me having white color inside, for example. So I can encapsulate the color. That's one design. So it's The same class dog with the color inside and the logic in the method, which says if the color is white, then true. If the color is black, then false. That's one design. And there's another in design. We can make white dog and black dog. So they don't encapsulate the color. They don't keep the data there. And their methods are just saying true, and this one says false. So now we have two classes here and only one class here. So which design is better depends on the situation. But in most cases, when you have a class and the amount of properties encapsulated starts to grow, and you have more than, again, like 5 encapsulated properties, then boom, it's a red flag. Something is going on. So more than 5 encapsulated properties, it's also something is wrong. So you better start making these subclasses, like classes which are decorators or subclasses or something like this. So an ideal class is up to 5 properties, up to 5 public methods, and many constructors. That's what I believe. And that's it for today. And no setters and getters. Forget that. So that's it for today. Thank you for listening. See you next month on the first Wednesday of the month at 11 Pacific time. Bye-bye.